Hey guys, not part of the plan, but not feeling well at all today. Um, Hopefully we'll be back tomorrow. We'll see. Started not feeling well Saturday, but we'll see how I feel tomorrow. Today though, not not so great. Anyways, today we are doing something new. Might be a little scary since I'm not there for us to take notes, but I promise it's not that hard. So first, volume of cylinders. Cylinders all it is going to be a formula. I can kind of show you this with the examples. Okay, the volume for a cylinder is always going to be the volume equals pi radius squared height. That's what it is, and that's going to be for all cylinders. That's just like cans. So any shape that's like that, that's terrible. Any shape that's going to be kind of like this, that is going to be this is going to be your formula. Volume equals pi times the radius squared times the height. I'll just leave this over here. So when you are going through and solving these problems, let me go back to the original. The question is find the volume of the cylinder with a height of 13 inches and a base diameter of 12 inches. Just in case you do not remember, diameter, sorry, I'm writing with just my mouse. Diameter, all that is it's 2 times the radius. That's all that is. So if I'm looking at this problem and I can see that the diameter is 12, that means the radius is only going to be 6 inches. The last tip I have for you, in Delta Math in particular, sometimes on other resources that we'll use, there is a pi button on the calculator. It's located right here. When you're doing this, I don't want you to use the Desmos calculator. It might still do the same thing most of the time, but for now, I want you using the calculator built into Delta Math. If you don't know where that is, it is way up here in the top right corner of your Delta Math screen. So when we're going through and solving this, we're just going to type in this exact formula. All we really need is this. Okay, so I'm going to type all this in, but I'm going to replace the R and the H. So pi times the radius. Well, the radius is 6, so I'm going to replace that. So 6 squared, I'm going to use this button for the square, and then the height. The height is, that's going to be 13 inches. And I just typed this into the wrong place. Typing that in there will get me the wrong answer. Oops. Type it into where the calculator goes. Pi times 6 squared times the height, which is 13. And it gives me an answer way over here. Of course, that answer is not going to be like an easy number. It's if we're dealing with pi, we're going to have some decimals. But it tells us here to round to the nearest tenth. So that means I need only these first few digits. I need this first decimal place. So when I'm rounding this one, I look at the number next to it. If that number is 5 or more, I'm going to round up. So because it's 1470.26, because that number is a 6, it's 5 or more, we're going to round up to 0.3. If this 6 over here had been a 4, 3, a 2, a 1, or a 0, we would have rounded down and we would have left it as 1470.2. So we submit our answer, and that's it. That's it for cylinders. Not much else happens. For cones, there's a little bit more that can happen. For cones, there is a different formula that we need. So for cones, that's going to be I mean, you guys have seen these shapes in real life before, but still. So a cone, it's a little crooked. The volume is going to be 1/3 times pi times the radius squared times the height. That's going to be the formula for finding the volume of a cone. So, going back to our original problem, this time they just told us the radius, so I don't have to do anything fancy. We're still going to be using this pi button, and this time it's going to be 1/3, let's see, pi times the radius, so the radius is 2.9 squared, times the height, which is 14.7. And once again, we're going to need to round for this. So let's see, this is 126.4. The number that would come next is a 5 or more. It's a 6, meaning I'm going to round my answer up to 129.5 instead of point 0.4. And that's really it, but there are two other tricky things that will happen today. One of which, let me just go ahead and skip to one of the problems that's like the issue that you're going to encounter. Here we go. So sometimes you'll get a problem that will give you the volume, it'll tell you to find the volume, it'll give you the height, but instead of giving you either the radius or the diameter, it'll tell you that the base has a circumference of 12.1 meters. Now, when that happens, excuse me, so when you are given the circumference, you have to use the circumference in order to find the radius. So circumference, that's going to be equal to 2 times pi times the radius. And you would actually have to solve this problem. You would actually have to solve that to find the radius first. So let's go ahead and just see how that would actually look in the problem like this. So it tells us the circumference is 12.1. So that means what I would do, I would set up the problem and I would start solving it. So we have 12.1 equals 2 times pi times the radius. And I would treat this like an equation. And what I'm going to do is I'm like, okay, well, it's 2 times pi times the radius. What if I divide both sides of the equation by 2 pi? Well, if I do that, pi's not going to be on that side of the equation anymore. And then I will have my circumference, which was 12.1, divided by 2 pi, and that's going to give me the radius. If you really kind of want to, you could kind of remember this as the radius is going to equal circumference divided by 2 times pi. That's kind of something you could very easily write down somewhere and keep. It's not an actual formula. This isn't a thing, but it's something we can use. So we're just going to go ahead and type that in. The radius will equal the circumference, which is 12.1, divided by 2 pi. And keep in mind, this is just giving me the radius. All right, that's all that is. That is just the radius. Um, I'm not going to round for this. When I take the radius, I am not going to round it. I'm just going to copy this for my radius. And then we find the volume of this cone, which is going to be 1/3, let's see, times pi, times the radius, which was that number. I literally just copied and pasted the whole number. That way we know that the calculator is going to do the right thing. Squared times the height, which was 9.1. All right, so this is what my calculator gave me. We're going to round it now. 35.34. So this is the first time we're going to round down. This one, it is 35.3. and we round down to zero point 0.3, not up to zero point 0.4, because the number next to it is less than 5. It's a 4 or less. So, gives me the correct answer. That's it for what to do with cones. I did include this one. Let me double check and make sure it wasn't anything too crazy. Uh, you know what? We're going, by the time you guys see this, there won't be a third one. I'm going to delete this other section, but those are your directions for today. These are basically off to the side over here. These basically are the notes we were going to take today. Again, sorry I'm kind of leaving you on your own today. Also, as a side note, the test that we took last Friday, the retest for it has gone live. The retest for it is right here in the retest section at the top of our Canvas page. So if you finish your Delta Math, this is something you can start working on. But that's going to be it for today. I hope that this video helps you. Please do your work. I will be back, if not tomorrow, then for sure Wednesday. I hope that start feeling better soon. Anyways, good luck, and I'll see you later.